Okay, just a few quick notes here. I'm here for kind of my office hours on Thursday. I just wanted to mention that I had uh, I had returned back the assignment one first assignments that were due on Wednesday for most everybody. So I posted a couple. I posted a new announcement just now on our class. So yeah, most everybody I think is familiar from taking the machine learning class in spring, but there's kind of some general requirements. So I had one or two people still not, for example, putting each task in an individual commit. So for this class, do put all tasks and subtasks in individual commits. And there's some other things on there. You can read those. But yeah, most people were doing most all these, although also we do have kind of very tight deadlines. So I'll just kind of remind everybody that you need to make an effort to submit all the assignments before the deadline on Wednesday midnight and Sunday midnight. And if you have something like an illness or an emergency, try and let me know as soon as possible so that we can work out and make some accommodations and things. But in general, make certain that you're following the workflow and getting assignments posted um, by the due dates, submitted by the due dates. So I didn't have a whole lot about the assignment ones. I still haven't gotten all of them returned back. In general, I can post example solutions. I don't think I really need to for the first assignment, but some later assignments maybe. We'll see how well or if anybody has difficulties with future assignments. But generally for these helps, I'm happy in these help sessions to go over past assignments, look at the example solution, maybe even post those if needed. Just shoot me an email if I haven't posted an example solution after I return assessments and you think it would be useful for you. I can do that. So I was going to also just see if anybody had any questions about assignment two. Let me bring up assignment two real quick here. So we go and open up my container for assignment two. And I'll just open the notebook right here for the assignment two. So it's kind of, I usually like running my notebooks from the web interface, from the Jupyter Lab interface, but you can, for example, get the same kind of outline for the notebooks from here in VS Code, and you should be able to run from VS Code. I think I showed this before. So it looks like most everybody, except for maybe one person, is using the dev container environment, which is great. So, in the dev container environment, VS Code, if you do want to run these, you would have to select a kernel first. So you should find that the environment is set up for you, but you do have to select that if you run the notebooks inside of VS Code like this. So, uh, anyway, for assignment two, what should I say about the? Let me know if anybody has any questions on these. This is really kind of really from chapter two. Okay, so this assignment two is on the chapter about the building blocks of neural networks. So I bring up my chapter two here real quickly. So in particular, if you haven't read these materials, it'll be very useful for you. But in particular, the stuff here about tensor products and tensor shaping and things are just some general stuff. So if you ever took a class on linear algebra, you might have seen some of these concepts, some of these ideas about working with a matrix or a tensor. These are often referred to as tensors nowadays, a multidimensional array or matrix. But in particular, what we're doing on assignment two is you're really kind of building from scratch a full workflow for a neural network. So, building the forward pass, and then this stuff in here about, taking a derivative and then what's known as back propagation to propagate the derivative through multiple levels of a computation graph. Okay, we kind of do that by hand for a simple 1 or 2 layer network to do a classification problem on the assignment 2. So really this chapter 2 stuff will probably be the most important stuff. But yeah, we're not using TensorFlow, even though you were supposed to read chapter 3 for this second part of the first week here. Not until the next assignment will we go off and start using Keras. And then later on, we will have some assignments where we have to do some lower level stuff with TensorFlow as well. Anyway, so back to this assignment. I won't say much about this. Hopefully, it's relatively easy. We are doing a simple classification with the data set that we give you for this assignment. So like the first task is to kind of load it and do some getting some warm-up exercise to flatten it and standardize the images from the data set that we're using on here. So yeah, we are using the data sets, this cat versus non-cat. We actually gave it to you in this H5 format, which is kind of a standard, it's not CSV, but it's kind of a standard. It is a binary format, so you do have to have the H5 library in order to read this in, but I already have the function created for you to read in the data set. You just have to add some additional helper functions to kind of flatten it and standardize it, so kind of normalize the image data set that we have here. Yeah, I forgot. We're not really working with the data set until the second task here. So we did give you some functions to read it in basically later on. So and I'll remind you again, if like I said, most people seem to be using the dev container environment, but if you're not using the dev container environment, you probably do want to familiarize yourself though with the requirements.txt. So, so if you're not using the dev container environment, create a virtual environment by hand using basic Python packaging, and then do a pip install using this requirements.txt file. So in this one, the only one besides kind of the standard things like NumPy and TensorFlow that we need for the assignment is the H5py for that, the H5 cats versus non-cats data file that we have. So I think that would be mostly all I'll say. Let me know if people have questions about implementing these. The forward pass is basically, you have to do a basic matrix multiplication for the way things are set up to do the forward pass correctly. The backward pass is going to be applying the derivative of our loss function from the forward pass, but hopefully you can kind of work out what you need to do. It's relatively simple, even though we're using the sigmoid function in here to apply the derivative for the backward pass. And then we are also, we talked about, if you were in my machine learning class in spring, we talked about gradient descent, which is really applying a forward and a backward pass iteratively. And the backward pass has to implement back propagation, so that if we have multiple layers, it actually propagates the derivative information to update the weights correctly back through multiple layers. That's basically that's one of the main things that the low-level TensorFlow or JAX level does, this automatic propagation for you if you're using the TensorFlow low-level backend for doing the automated differentiation over a computation graph here. So we're implementing that kind of by hand. Once you have those pieces, then you can optimize iteratively using a gradient descent. So you just apply a forward and backward pass, update the weights based on the derivatives, and do that some number of fixed times. In this assignment, you just have to implement the full gradient descent to run some number of iterations. And then the final task 3 puts this together. So actually trains it on the cats versus dog data set and see how well your hand-built neural network does on predictions on training and test data. Um, okay, and what else? So I think that was all I was going to mention today during kind of our help session. Let me know if people have questions. Assignment 2, that is due on Sunday then, or second assignment. And I already brought this up on Tuesday, but kind of, you were supposed to also be reading chapter 3 here now for the second week of our, sorry, the second part of our first week for the class here. But So I had mentioned, so if you have the second edition, I've just got the second edition of the textbook here. It only talks about Keras and TensorFlow. So here was the first kind of difference that I saw on the third edition. It was a good expansion of this. They talk a little bit about PyTorch and also JAX. So here, like looking at this figure, if you watch my video on the chapter 3 stuff on Keras and TensorFlow. You can kind of think of TensorFlow as a low level, kind of above directly sending stuff for computation to the CPU, GPU, or a TPU, a tensor processor unit, if you have it. So PyTorch actually kind of implements both layers of this. So PyTorch has an upper layer for doing deep learning models, so doing the different kind of layers, like we'll talk about in this class. And it also implements like the lower level for doing the tensor manipulations and a computation graph and automatic differentiation. Okay. Another low-level library that's talked about in the third edition is JAX, which is an interesting one. I don't know if there's other popular low levels here besides like TensorFlow and JAX, or just using PyTorch for the whole deep learning stack here. But JAX, I'm just interested in it because I ought to try it out. It's a Google kind of thing, and they've got lots of these tensor processing unit sorts of resources. So it uses a functional programming approach, which makes it easy to automatically parallelize stuff much easier than when you're not doing things where you have global variables and stuff like that. So anyway, and the last thing that I'll mention, I was trying to remember it on Tuesday, but there is a little bit of a discussion of in my lecture video. I thought it was in chapter 3 here somewhere of yeah, oh yeah, there it is. So setting up the deep learning workspace. So this was section 3.4 in the second edition, and that section should be still in there. So I was trying to remember the collab. So another thing you could check out for this class, if you don't have a GPU, there is some amount of free GPU processing available from Colab. I don't know how much. I'd be interested. I mean, I've used it before. I don't know how much right now they give you to like request a GPU, or that sometimes we've been able to actually request a TPU. But I don't, that should work with TensorFlow. But you might have to make some changes to get a TPU resource to work. I'm not certain. But anyway, that's another thing you can check out. Or you can just try and do it by hand. Probably the best thing to do if you are like just doing it locally on your own system, not using VS Code or dev containers, is to at least use a virtual environment and do a pip install of the requirements. It should still be okay as long as you're using the same libraries that we set up for the assignment in the requirements.txt for the assignments, or for the lecture notebooks in the class repository. All right. So yeah, that's all I'm going to mention on this. So again, as usual, if you do have questions, jump on for these help sessions. Although, if you're not available on Tuesdays and Thursdays, or at least not in the mornings, just email me, and I can be available on campus. Or we can set up a Zoom session at a specific time. I'm usually available. Mostly Tuesdays and Thursdays are best for me, but I could do Monday, Wednesday, Fridays, depending on certain things. So, as another note, I might post on this, but we do have some department job interviews happening next week on Tuesday and Thursday. So I might have to push back the 11 o'clock, because I know we have some stuff from 10 to 11, but we'll see. So I might not have to do anything, but I might have to be late or move it around a little bit next week on Tuesday and Thursday to be available for the online office hours help session. So. Okay, that's it. I'll go ahead and post this, and just let me know if there's any questions or email. Hope everybody's is enjoying the course so far, and I will talk to you all later.